So this week we're going to be talking about concurrency and specifically about threads, runnables, and executors. Um, so every time that a program runs, it runs inside of a thread or basically a process. But there are times when we want to run multiple processes at the same time. And this is used tons of times in our everyday lives, but we sometimes don't notice it. In fact, it's implemented this way so that it makes our life easier. An example is, let's say I'm using an app on my iPhone that has to go out and make a call to a service, a web service that's external. More than likely, that application is going to run that call to an external service as a separate thread so that the application that I'm running doesn't pause to wait for that call to happen. It's kind of as if it's happening in the background. And that's exactly what happens with concurrency. There are lots of different examples of it, but that's a pretty simple one. So I'm going to be showing you a really simple way of doing concurrency. Concurrency is built into Java. It's a very robust service in Java, as good or better than just about every other language out there. And it's very simple. So the basic building block of concurrency is a thread. And there's a class called a thread. And so you could build a thread in and of itself, but the other way that you can do it is taking a regular class and making it a thread by having it implement the runnable interface. So I'm actually going to take that approach. So I've just created a class here called doing something, and I'm going to implement runnable. Notice as soon as I did that, it underlined in red, and that's because with this interface, it requires a public void run method. So as soon as I type that in, all's well. Okay, so basically what we're going to do in this class called doing something is basically just do something. And we're going to have multiple versions of this class running as different threads. And so we want to make it such that each of those does something a little different and takes a little bit different amounts of time. So with that in mind, first of all, I'm going to create a constructor. And I'm going to have this constructor take a name, take a number, and take a sleep amount. And so with that, I'm going to create four private fields. Name, number, you guessed it, sleep, and one more I'm going to call rand, which will be a random number. Oops. It'll be a random number. Okay, so inside my constructor, I'm going to do just the usual. This name equals name. This number equals number. This sleep equals sleep. And then I'm going to use the random number generator. Equals new random like this. Notice it's highlighted. A little trick in In IntelliJ, I can go Alt Enter and it put the import up there automatically for me. And now I'm going to set rand, this rand, just to keep it all the same, equals random new next int, and I'm going to say 1,000. So it'll pick a number between 1 and 1,000 that will go into that. Okay, so that's good for our constructor. So with a runnable, when it executes the thread, it's going to run the runnable automatically. So this is where really the meat of it goes. So what I really want to do is, a whole bunch of stuff's going to be coming down here in the log or on the console, and so I want to make it really obvious what's happening. So the first thing I'm going to do is we're going to just let everybody know which of these is executing. So we'll print the name. We'll print the number. I'm going to break this, take this back down here. Oops. And we'll put the sleep setting. And we'll put the random number. Oops. Can't type this morning. All right. And I'm going to add, even though print line has is already going to give us a carriage return, I'm going to put a couple more in here just to make it really obvious. You'll see why in a minute. Okay. Now, really the meat of what we're going to do here is in a for loop, because we're going to go through a series of steps a certain number of times, and it'll be different just depending on the parameters. We're going to count starting at 1. Count is less than our random number, and count plus plus. And then inside our for loop, I'm going to do something a little tricky. I'm going to use a integer division using the modulus, which is count. This is the remainder. The remainder of count divided by number. If it equals 0, then we're gonna do something. That means if it's divisible, basically. Let's do it without a print line on this. Name plus is sleeping. We're going to make it sleep. And we'll use this command. We have to put it in a try catch. We're going to sleep. And we're going to sleep the amount of time, this is in milliseconds, that the variable sleep was passed in. And let's finish our catch. It's interrupted exception is the exception we have to catch. And we'll just toString. There we go. All right. So it's going to continue to go through this over and over and over and over again. And then let's tell it when we're done. By saying name plus is done. And then, like we did on the other one, I'm going to put a couple of these in here and a couple of them at the end, just for some separation. All right, so we've got our doing something done. This is really the meat of what's going to be happening in our program, so I'm saving that. All right, so I created another class, and this class is executing doing something. Yeah, I know, we're really creative on the names here. So we'll just put this inside of a main. So the first thing we need to do is, so we're going to be using executors or executors. There's a bunch of different things you can do. They're incredibly powerful, but they're a way of managing threads. And we're going to use a thread pool. And we can specify, we'll use a fixed thread pool, which means we can specify how many threads it'll be used. But it will actually queue up more threads than what it has, or more processes than what it has. So let me show you how to do that. So we're going to start with an executor service. I'll call it my service. And equals, we're going to use this new fixed thread pool, and we're going to give it a number of threads of 3. Now, notice this is not showing, so I've got to say Alt, and it puts it up there in the import. All right. So what this means is I've created a pool that can hold 3 threads. And these are runnables. It'll hold runnables or callables. We're not really getting into callables during the class. Runnables is a little simpler to do. So let's instantiate a bunch of our do somethings. ds1 equals new. We'll use our constructor. We're going to pass it a name, a number, and a sleep amount. Okay. And then I'm going to actually copy this thing. We'll do 5 of these. Doing something 2, doing something 3, doing something 4, doing something 5. And then we'll change the amount in here. Sally, Billy, Anna, and 1 gender neutral, Pat. We'll change the numbers, and I'll get them smaller as we go down here. 5, 2, and 1. That's going to run basically sleep every time. Because of that, I'm going to make the sleep amounts lower as we go. There's not really anything to this. You could pick whatever numbers you want. I'm just trying to be fancy about it, I guess. All right, so I've instantiated a bunch of objects. Now I've got to execute them. And I use my service, and I use execute, and I put in ds1. Okay, and I'm just going to, again, copy this. 2, 3, 4, 5. So I picked 5 because there's only 3 threads. So what's going to happen? It's going to do 3, and then it'll have to wait until one of the 3 are done so it can do the next one and then the next one. Now we always have to make sure that at the end we shut down. You might notice if you don't include that your program never stops running. You'll have to break it in order to stop it running. But with shutdown, there's 2 different kinds of shutdown. This shutdown will wait until all of the threads are neatly completed before it shuts down. There's also one called shutdown now that will shut down immediately, so it won't wait. This is the best one for us. All right, so let's run this sucker, shall we? Down here in the console, I'm going to make this bigger. We're going to see what happens here. taking forever. All right. You can see that things are happening. You can see that we got Sally and Bob and Billy, and now one is done, and so now you've got different ones. Now we've got Anna in the mix here. Anna and Bob and Billy, and Anna and Billy, and they're going by too fast to really read. In a minute you'll see that another one gets done. And then finally we can start adding Pat to the mix. But it looks like Anna's taking a long time to finish. There, that one finished. Now we had Anna and Pat, and now we just have Pat, and I guess Billy's still in there. He's taken a while. There, now Billy's done, and now we just have Pat finishing up. Pat doesn't sleep as long, if you remember. And now we're done. All right, so I'm going to come back over here to the left so we can see really what happened. Let's scroll up to the top. So we started with Bob, and then Sally, and Sally started sleeping, and Bob started sleeping, and then we added Billy, and Billy's sleeping, and Sally's sleeping, and Bob's sleeping, and they keep on going. Now Sally's done. So we add Anna, because remember we can only have 3 going at a time. Now we got Anna and Billy, and Anna and Billy, and Anna and Billy, and Bob, and Anna, and Bob's done. Now we add Pat. Now we've got Pat and Anna, and Billy's in there, and now Anna's done. So remember, Billy started before Anna, but Anna finished first, and now we got Pat and Billy, and now Billy's done, and now Pat, and now Pat's done. So you can probably see why I added all of those extra carriage returns just so you can see it. So this is a simple program that uses a runnable, which makes any class a thread. So we've got doing something, which really becomes a thread with this runnable implementation, which basically just does here and runs something that takes longer for different ones than others. Within our execute doing something, we use this executor service, and we create a fixed thread pool of 3. We instantiate a bunch of our doing somethings, and we execute them. And at the end of the process, we shut down.